the Soma cube. So I'll take a picture of the plastic toy piece that I haven't put in with this this page. Oh, I was going to put that in the list of videos. So I haven't done that yet. All right, so I'll get that up for reference so that so when you're watching the video. So one of the things that I think have been a limitation is that I've talked a lot about subassemblies, but we haven't ever created any subassemblies or any real in-depth subassemblies. Okay, so going through 5.2 and generating the 16 or 17 parts either as individual parts or making them configurations and having the 3 or 4 parts, we're going to have some strategy to build our geometry, put it into an assembly. So the only thing that really makes an assembly is that an assembly or a subassembly is it embedded in another assembly or is it standalone? Right. So one of the we'll start off with the general descriptions, but when we talk about, and I think the other videos have probably the good explanation. When we talk about the assemblies, we're talking about 6 degrees of freedom. That along each of the axes, X, Y, and Z, we have linear movement, and then rotation about each of those axes gives us 6 degrees. In order for this to be fully defined, fully static, we have to contain, we have to control, we have to put mate references on all 6 degrees of freedom. If our intent is that this be dynamic, probably not that dynamic for the puzzle, we just want to put it together. But if we want it to be dynamic, then we're going to allow one of those degrees of freedom to remain underdefined and cause the movement. That is not going to be the same as creating an exploded view. So if I put this puzzle together and I want to see it in the way that the assembly instructions, I'm looking more for an exploded view, not to move or create new and different mates to make that happen. All right, so I'll kind of I'll fall back on the other videos. The spring of 2016 videos, I think, had a lot of the base information. We're going to revisit all of that, but again, the intent is to have new and different material and fall back on the base material that's already been generated. All right, so setting up for the cube. Size-wise, if each of these blocks is 1 by 1, I have 1 part. And that 1 part is, well, it doesn't really matter what size, but we'll say this is a 1 by 1 by 1 cube. That is part number 1. We're going to have 4 instances, 4, 4, 3, 4, 3 in every subassembly. Right, so I don't need different cubes. I don't need different parts to make this work. I need the geometry just to get it started. Okay, so we'll come back to that. Oh, and I didn't launch. All right, so 2017. I'll get that going. All right, so since that's launching, I'll jump back in. So really, the base where I pick the origin isn't oh, okay, my HSM, well, that's going to be interesting. All right, I need to update my HSM and my CamWorks and my all right, so all the cam products are trying to launch at the same time, so I did not get those turned off in 2017. All right, so the 2018 CamWorks and the commercial CamWorks licenses, we will make sure that all of those get turned off at startup. Yeah, get that out of the way. And pretty much a lot of the add-ins are in that same kind of yeah, just double checking that I really don't have anything launch at startup. If I want it, I will turn it on. All right, so Still kind of cracks me up. All right, so the only real question is there any advantage on this geometry to putting the origin on a corner, putting it in the center of the part, putting it in the bottom center, the bottom middle, any one of our locations? Don't see one. So just drawing it and starting, maybe a couple of assemblies in, we might see something and want to make the adjustment. But going through the process, I don't even really see any downstream negative effects of moving the origin around if I decide there's a better way, because the assembly mates are still going to participate in the way that I'm defining them. All right, so first part, let's go with the front plane. And again, the cube can be any size. 1 by 1 is a nice number. And oops, got button happy. Come on. All right, so I wonder if my battery's going low again. All right, so maybe time to recharge. And getting a little, and we'll set it to equal. All right, and then features, extrude boss base. And it would be an interesting experience experiment to go ahead and make this to where that size can drive in multiple directions. So let's make the material something interesting. So since our block is plastic and pretty much all right. So acrylic may seem like a good idea. Let me tell you that it's not. If you're going to work in glass, acrylic, anything that naturally has transparency, you often end up picking things that are closer or further away because it is calculating through the transparency. There is a setting back in the options that says pick or not pick, or I need to hold down the shift button and then, was it shift? I need to hold down a button and make the selection so that it finds the first object and doesn't look through the transparency. All right, so that being the case, pick anything that is polycarbonate, ABS polycarbonate. Yeah, that probably wasn't much better. Nylon, polyethylene. Go with an all-purpose PVC. It's now a plumbing product. All right, so we can always change that later, but while we're going through the initial steps, I want to build this out. All right, so under the tools, and let's see if this will come down far enough. We'll get the equations, and my global variable will be size, and 1 inch. And that did not give me the dimensions, so let's look at the equation view. There's my dimension view. So instead of going back into the modify box, instead of going to the double click on the sketch or on the feature, there is the list of my dimensions. And so if I do a highlight and set to equal, there is my global variables, there is my size of 1, hit the checkbox. Equals global variables, size of 1, evaluates to 1, hit the checkbox, and OK. All right, so what that does when I click either one of these is we've set the equation, the global variable. Still having some problems with the mouse, so I'm going to switch. If it's still over here, I'm going to switch to the other mouse. Okay. All right, so rather than setting a linked value, typically the linked values will just be within the sketch. And so that gives us the kind of the chain link looking thing. The equation in front says that I can go back to look at the equations. There is the evaluated size, and when I manage equations, I decide that size needs to be 2 inches and hit OK. Then it's going to increase in size, and it's going to do that increase everywhere that I've set a dimension equal to size of 2. All right, so we're going to stay with the size of 1. And then we'll go ahead and save this. Let's see, let's go ahead and create a new folder. And this can be block. The names need to be of sufficient complexity that this will only ever be the only block. That I don't want it to be able to confuse, because SolidWorks sees the first block in the assembly and says that must be the one you want. If I have 3 things and they're all different that are named block, there's going to be a conflict. So if I have a Soma block or and then 3 other names, as long as they're unique, I will avoid those conflicts in the naming. All right, so once you move over into the realm of the assembly, we're gathering up those new rules. What are the references? Where are these things going to be located? Are they scattered all over the network? Did we take a 500-piece assembly and dump it all into the same folder and hope for the best? Good luck finding anything. We need to have that structure, have those folder structures to make this manageable. All right, so I've created the part. We finally get to a point to where I'm making the assembly, new, and assembly inch. All right, so to begin the assembly, it automatically jumps into, shows us the open file. So if I create a part and the assembly is open, or I open up a new assembly, it says you must want to put something in here. And that's not always necessarily the case. We may want to generate a layout. I may want to put in a sketch. I may have other things that I'm intending to do with this assembly, but most of the time we're going to pick our open part, a base piece, and that's going to get us started. All right, so as far as position, if I go right to OK, we're going to be origin to origin. So let's go ahead and do that. Takes the origin of the part. So if I expand this out, there is all of the information contained in the part. Its planes, and if we zoom out a little bit, we'll be able to see the part planes. And then at the top are the assembly planes. And then the origin of the assembly and the origin of the part. So by allowing it to fix the first part, this little F in front says that I hit OK, take the origin and the orientation of the front, top, and right planes of the part and put them in the assembly in the same fashion. If something happens and I realize, oh, I really should have rotated that, then we have to float. And right-click and float will release it. We'll release that part to be able to move, rotate, go to another position. Okay, so we don't need to do that just yet. We'll see where we get to with it. But be aware of the F and the float. If it's float or it's brought in separately, then it won't have anything in front of it. It'll just be the name. All right. So my favorite way to put this is, being Windows, there has to be 5 ways to do everything. So we brought in the first one to begin the assembly. Next one will be to insert component. Let's see, do I want to do that one first? Yeah, we'll do that one first. We'll go to the easy one last. All right, so I go in, I pick the block. If I were to pick the check mark again, I would have a block on top of my existing block because it would go origin to origin and fix as well. So I don't really want to hit the check mark. I want to drop this in relation to the other part where it's convenient to get to. And then in the options, we saw that we turned on this this box for rotation. We don't really need to rotate these. Probably when we have the sub-assemblies going, then we'll make a rotate or do something to that effect. And this part then, selected component is fixed. This part is capable of moving, and I'm still having some issues with my mouse not quite being smooth. Okay, that's a little better. And then there is always the rotation. We're rotating the view as opposed to, let's see if it'll let me have it, as opposed to, well, I'll just go into rotate component, as opposed to we're rotating the component. If you don't have something existing in reference to, it's very easy to lose your perspective of, am I rotating the view, am I rotating the part, am I moving the view, am I moving the part. All right, so if we go with the alt in middle, let's see, that was the rotate, the control in middle, we can kind of tell that we're moving that view as opposed to moving the part. But it's easy to get in when you get in that hurry and you've got all these other things going on the screen. Probably one of the most frustrating things starting with the assembly is I'm telling it to do this, but it's doing this. And it's usually a mismatch of that perception of what's going on the screen. All right, so I'm going to rotate that over, and we're going to start with the mates. Okay, so I'm big on pre-selecting, so the very first one we're going to pre-select. We have planar faces. Those are a good place to start. They make the most sense. And just like in the sketch, we're going to have coincident, parallel, perpendicular. Try not to lock. Lock's kind of one of those hokey solutions, kind of like fix in the sketches. We can usually find a better way. The distance, the angle, and then profile center. Profile center is one that was added in 2016, and it would look at the area of this face and relate it to the area of this face, pretty much applying coincidence and centering it in one shot. Haven't gotten used to that one yet, so I'm still working on profile center. So we'll stay with the foundation pieces. If you don't recognize the pop-up, then you're going to go into the paperclip for the mate references. It shows you the items you selected, and it is making those coincident. We also have two solutions. One solution aligned, one anti-aligned. So if I don't like the direction, I can flip it around. So the first direction was okay, and we don't need to anti-align. Adds coincident to the group. Now that we're clear, I can go to the next face, rotate around, and pick another face. Those are now coincident. And then last, we'll go face to face and coincident. So now I have the two blocks, and both are defined, one by virtue that it was fixed when it was brought in and placed origin to origin. The other one is fully related to it. Okay, so at some point the little blue dots start to take over our origins. Once I have that that kind of orientation and location defined, I'm going to turn off the origins and make it so that I'm just in that kind of in that view.
Is there any easy way, after you have a bunch of things brought in, that you could highlight, show which one is the fixed one?
Yeah, you just, anything that you select is going to highlight, and anything that you select over here is going to highlight over there. So it's that dynamic selection, or whatever they call it, where anything in the feature tree that you pick, at the very least, it's, in this case, it's in orange. Kind of depends on the version, but it's kind of enveloping on the orange box, and showing you those, giving you again that visual clue to identify the parts, and then picking on the part. Even so far as if I had multiple features in here, I could pick on the feature for that part, and it would show me down to that level if I needed it. All right, so we did insert components. Insert component existing part in assembly is the exact same thing as insert component on the toolbar. So it's kind of another one of those, when I fall into old habits, I often do the insert component, and it's the same as hitting that or picking the button. So the Soma block, we'll place it. And then this one we'll do with planes. I think that probably the face-to-face, those planar items make the most sense. You know, when we're playing with our Legos, when we're playing with our blocks, we pick up the block, we put the two blocks together. You know, that's a physical game that we can pretty much relate to. So we're doing the same thing here. What doesn't make as much sense is when I would need to go, if this is cylindrical, it has the ergonomics, and I don't have planar, nice, convenient planar surfaces to work from, then I'm looking for planes. And so the front plane can go to the front plane, or the front plane could go to another face. All right, so we'll go to the main. That brings it up coincident. And we need to expand out the flyout. So the flyout gives you access to that geometry. And so in here I want to make sure I'm in the very last one, the one with the minus, because it's easy to have 2 or 3 of these expanded, and oh, I'm picking this one, but no, that one's already defined. All right, so we need to kind of watch where we're making that selection. All right, so top plane on that block can go to the face on that block, and then the right plane of the assembly to the right plane of the block. All right, so my hierarchy, I would say plane to plane, plane to face, face to face. All right, and there are times where you're going to mix and match all of those. All right, so what we can do next, and you're going to get really good at rotating. I'm getting really twitchy on my rotating right now because of the mouse is kind of annoying me. But we come over to the File Explorer, and I tried to use the File Explorer just a little bit more, but there is my block. I can drag from File Explorer in and make it the shape, or drop the shape in relation as well. All right, so we said plane to plane, plane to face, face to face as my hierarchy. Lesser choices are going to be edge to face, edge to edge, point to all of the above, point to point. All right, and there's going to be some reasons why. So if I go edge to edge and make those coincident, and I'm going to jump in, I'm going to bypass going into the mate property manager, and it will go right edge to edge. All right, now I'm able to rotate, and that whole you are responsible for 2 objects occupying the same space. Yep, I can't quite get it to rotate the way I want it to. 2 objects occupying the same space, you're responsible for gravity. If it needs electricity, water, oil, any of an air, you're responsible for all that too. Software does not care that these are intersecting. It will tell you that they're intersecting, but if you want them to intersect, power to you. All right, so edge to edge, and then we would go edge to edge, and can't really get to a mate alignment with that one. So to edit the mate, keep in mind that you have all of the mates. As we get through, this mate reference can be hundreds of mates. Right, so this is not my first choice to get into. Underneath each of the parts, as we add a mate, mate in assembly 1. All right, so I need to edit that mate or edit that feature. So that one's okay. That one's the one that's not helping me. So I can see the previews of it along the edge. And let's see, edge 1. And the numbers at the back are instance counts. You are always incrementing your instance counts. So as I bring in the next part, instance 1 of Soma block, instance 2, instance 3, instance 4. All right, so I brought in instance 4. That's probably the one that I don't want. I go line it up with the next one. It did a nice reverse for me. Let's flip the mate alignment. That put it where we want it. Okay. So I got away with 2 mates there, edge to edge. Problem is that if there is something happens to this mate, this is going to be able to rotate freely on that dynamic motion on those faces. So I'm still going to say edge to edge is less of a preference. Okay, so this becomes. Actually, I started with 7. I guess we should have stopped at 3 and gone to 1. All right, so this is going to be SubAssembly 7. And if we wanted, since 4 is in the mix, I can delete it. This lends itself to the whole configuration thing again. All right, so in the parts for the E-clip, we made different sizes. Here we're controlling suppression states. So I already named this item 7. So do I name it item 1 and 7? Yeah, so I have to come up with a naming convention that covers my configurations if I'm going to go that route. All right, so just real quick as an example to bring this in, configuration manager, very top level, add configuration, and this would be configuration for item 1. And we'll use the configuration name to show up in the bill of materials, and this is the 3-block L-shape, something like that. And what that does is the default was 7. I don't want to delete it, but I want it to go away, so I suppress it. And in controlling that suppression state, I now have something that default is 7, and the other configuration 1, if you let me have it, is 3. Or sorry, 4 blocks, 3 blocks. Yeah, I'm still processing that one with the name. All right. So at this point, we haven't inserted this file into anywhere else into a upper level assembly, so there is no reference for it. So I can rename it if I want to. To be on the safe side, and again, not the last word in the renaming, but certainly better overall, is to go into, and I picked wrong, but that's okay. No, Dropbox. We'll go into the SolidWorks File Explorer, and the File Explorer has that group of tools that says when I rename this, let's see, do I want to be there? Probably want to be there. So 7, I go into the rename. It's looking as the used by and used as. So if this block is used in the assembly, we'll have to come back to this after we've created the top level assembly, because we're going to see that this was used by the assembly when we get to the block. That part is going to show up a bunch of places if we tell it to rename the Soma block. All right, so here I can say 1. Okay. I don't really want the ampersand squiggly telling me in, so we'll just type it out. Okay, so I can reduce that, get it out of the way. All right, going into the next item, let's find our next group. So L shape, we did the 2 L shapes. We could do the 3. Actually, I was worried about doing all of these as configurations, so there is a way to do all these as configurations. I don't know that I want to go that far into it, all the suppression states. So we're going to have a mix of where it makes sense. We'll let it make sense. All right, so I'm back into the Soma block, File New, Assembly Inch. We're going to bring in the block. Go ahead and hit OK so that it's in place. Really should have turned off those origins at the assembly template level. All right, so we went File Explorer, we went Insert Components, we went to Insert. Under Window, if I were to tile horizontally, I can drag from the part into the assembly. And we did that a little bit with the drawing templates, being able to drag from one window to the next. So face to face, and we'll go coincident, face to face, coincident, and face to face, coincident. All right, that's my preferred. Let's see if Windows Explorer is still up. Oh, we're over here, so we can get back into the puzzle. And if I reduce that close enough, I can come over to the block and from Windows Explorer drag into the work area. All right, and then face to face, face to face. Well, let's do. We did the edge. And so that gives us the coincident. So edge to edge is not quite the same as edge to face. Let's see if they'll let me have it. All right, so in this case, that edge is free to move all along. It's the coincidence that's telling it. So I really already have coincident. I don't need to add that additional mate. Right, it's still going to move. It's still going to move kind of weird. So maybe the guessing is that we would go to face to edge along those items, along those directions, and put it in place. Okay, so fully defined. And then last, and probably my preference for same instances, is that you hold down the control button and you drag. You can do that from the work area or from the feature tree. Okay, so point to point is always interesting. So let's go coincident, and it's capable of moving in all directions. And if we go point to point, now it's able to rotate about the axis, not unlike the edge. And we go point to point, then able to move. So again, the downside is if something fails on this geometry, it loses. We're going to have some really weird rotations. Face to face, plane to plane are always going to be the most stable. And this was item 6. Okay. New tools. So we have 3 out of our 7. File new, assembly inch, and we'll bring in the first part again. Okay, so kind of the last in the group is we have the ability to set a mate reference. And mate references on cylinders will give us the coincident and the concentric. I've tried to follow the logic of the naming convention. We'll try it, but it always ends up a little strange for me on the mate references. All right, so you have the primary, secondary, tertiary reference entities. All right, so we're going to place one and set for the face, default, coincident, whichever. Go into the second and pick a secondary reference. And then the tertiary. All right, so it's been a long time since I've tried this, so I have no idea what we're going to get. So as long as the naming is, and these being the same part, we have at least a chance of it working. What this is going to do is, as I drag to that face, I'm automatic coincident, and it picks up the coincident. And then, okay, what happened to my secondary and tertiary? So those I still have to go ahead and add. So most of the time I don't even bother, and I don't even bother with the secondary and tertiary. I just go to whatever geometry is going to speed up the process. And even if it rotates the part, well, these are blocks. I don't really care about rotation. So this one can go over here, and I get that first mate. It's in position. Go back to the coincident, and all of a sudden I'm clicking away, and I've got these blocks going in. I need to double check and make sure that I'm telling it to go the right way for number 2. And we'll bring in another instance. It goes to the face, okay. And then rotate around, coincidence. Okay, so that was 3. Come on, let me have it. All right. Nope, that was 2. So I get to go rename again, because I can't count. All right, so back into the File Explorer, and that did not update. So the refresh. One of the limitations, I don't think the refresh is that great. So double click again, rename. Still don't have a used by. So 2. Oh, and since it's open, it's not going to let me, so I need to close it. All right, so the Windows file structure is not going to let it rename until it is not active. Okay, over to item 3. That is the little tab. All right, so we'll go to the corner. Come on. Go into the assembly. And off the mouse pad will help them. Picking the Soma block, let it go to the fixed. Ah, missed something. It didn't quite jump. So that being the case, it got one coincident, or my mate reference is now trying to interfere, but still it should have gone right to the origin to origin again. So I'm not sure what I told it to do there. All right, so this one's going to get a float. I could delete it and try again. Let's see what it actually generated. Since the mates are there, there is an existing mate. So the face and the top plane, go ahead and accept. Let's go with the back and the front plane. All right, check the isometric. And you'll notice that I kind of keep jumping back to Control 8 or to the isometric to keep my frame of reference. I'm sorry, Control 7 for isometric, Control 8 is normal too. All right, so staying with the instances, let's bring one in. It finds the face, face to face, coincident, face to face, coincident. All right, probably, say, kind of thinking back through the logic of the edges and the points. I think the face to face is just easier to pick. I'm not searching for geometry. If it's big enough that I can see it, I'm going to be able to select it easily. All right, other than trying to fight the smaller. So that should generate an error since I went ahead and clicked. Let's go ahead and see what it does. All right, so mate type, it's not looking for, it could go particular. So since I can't see that geometry, let's say that I needed to have that geometry. All right, I can rotate around and I could go face to face. On the off chance that that is my critical geometry, there's some reason that I need to have one of those faces. We're going to right click, and let's see, we have selection. Nope, we need to be in the mate first. So mate for the first item, right click, and then we're going to have select other. That select other will let me pick a face that is behind something else. And then if I'm not sure which face, well, that's extrude 1. It's not quite coming out far enough, so let's see, will it give me the instance count? Be nice if it went a little further over on the instance count, but I have one selected, and that will have to do. All right, so the right click and select other shows up at different times, but definitely when you're in the in that operation or telling it to do the mate. All right, so probably in this case just as easy to flip around, coincident, coincident. And I don't want to keep renaming, so I'm going to jump back over and verify that that is item 3. And we'll close it, new assembly. All right, item 4 was the kind of the opposite of 2. And still trying to rotate that and get it to work as the same thing. So origin to origin, and that mate reference may be the one that's either the secondary or the tertiaries are trying to jump out at something. So we're gonna try that real quick because I haven't put those in and had that issue. Oh, it cleared both of those out. Oh, I'm telling it the same mate reference. All right, so mate reference is another folder that gets added. So I don't want to add another mate reference. I want to edit the existing. So I'm going to go find its default, and we're going to take those 2 faces out just in case they are the ones that are causing the jump when I'm putting these in. So let's leave one out of position. This is fixed. The origin of the assembly is here, and the origin of the part is here. There are implications. Most of the time, my perception is I know where the origin of the assembly is, and typically it is somewhere along this geometry, but it doesn't necessarily have to be. All right. The other thing is that we haven't done anything really with symmetry, so if this becomes a problem, then we'll go back and catch it. So unlike this sketch where everything has to be related, or one thing has to be related back to the origin to get to fully defined, not so much the case here. All right, so one's gonna, well, let's go ahead and drop it because now I'm looking at, let's see if we go that way and then that way and then that way, that would work. Set the mate. Okay, now we'll rotate over. So all of the mates are going to participate and work. My origins are getting a little strange. All right, and then I can check at any point that it is fully defined. It is it's not moving. And apparently hit the control button too fast. Select, control. All right, how about control and select? I stopped and thought about it, so I got myself in trouble. So holding down the control button and then selecting and dragging. And now I'm just getting button. So there we go. And that was item 4, and that leaves item 5. All right, so once those origins are turned off, I guess the real issue here is that when we slip over to evaluate, well, let's go ahead and turn those back on just temporarily. The default is the for the center of mass for our values under mass properties is the origin that is back and over here. All right, so that distance is not in relation to physical geometry on my assembly. It's floating out in space from the 0, 0 point. All right, so that would probably be my main concern, is that coming to the center of mass or to the moments, if we're going to use those for calculations, and I'm not sure where that default origin is, that's going to be a potential problem. I would either have to place my own coordinate system, or we're back to going ahead and just putting the definition in for the original part. So hiding and showing. All right, so where we suppressed before, I just want to hide those, because when I float this, we're going to try something a little different so that we can use the other mates. All right, so we'll float. That frees the part, and nice, got some errors on that one. Not sure why. Maybe it just needs to rebuild. Top plane, and then if I want to center this part, we have a different mate called a width, or we could probably go probably need to go symmetry. All right, so standard mates are the coincident, parallel, perpendicular. What you end up using the most of is probably coincident, concentric, and distance. The others are specific to geometry, and you may use them, just not as much. Collapse that menu. We go into the advanced mates. Then we have that profile center. We need to do one of those. We'll do that on the last one. So let's go symmetry. And I will pick the symmetry plane. In this case is the right plane. And the faces to be symmetric with are the two outsides. So they need to be parallel to each other, would help. And we go ahead and accept. I can check. We're able to move back and forth, not up and down, not side to side. So let's try the width. And width is a slot A into tab B. So I need two pieces of geometry on my selection to go with two pieces of geometry on the other piece, so on the tab piece. So probably not going to work on that. Profile center, not a good one. Let's just stay with symmetric. We'll go with make sure I'm in the symmetric plane, so the front switches over to picking the faces, and we'll set the plane that way. All right, so by setting those three mates, I now have a list, but basically the last in the group, because I put them in last, I have the coincident and the symmetric. So if I were to put, if I wanted this centered on the origin, I could do one more symmetry for the top and bottom of the cube. So starting off, the recommendation is you're going to do a lot of coincidences. All right, so face to that whole plane to plane, plane to face to face, you're going to be doing a lot of coincidences. And then you'll expand out from there. All right, so control selecting or shift selecting my group. I can show those again, and we'll save for 4. And the last one, 5, is the little shape, the little Z shape. All right, so we're going to see if this jumps again. All right, so I'm not getting that weird, angled out in space. So whatever the secondary and tertiary we're doing, it's still doing it. Never mind. So it fixes it. It's in space, and it adds a mate and suppresses it for coincidence. All I can really say is most of the time mate reference parts are not the first part to come into the assembly. So I don't know that I encounter this that much, but it's something now that I've got something else, kind of like the sheet format thing, to go figure out why that mate reference is doing what it's doing. All right, so we float this, we float it, this becomes active. that mate was suppressed while it was in the fixed. And we'll go ahead and we'll set for the top. Rotate into position, set for the right, and go to position. Alright, so still able to move. So somewhere in there I got a duplicate. Alright, so diagnosing my duplicate is that one's highlighted. Alright, so somewhere in the rotation I managed to pick two of the same thing. So we'll edit. And I can just clear. And we'll pick the back and the front. Go ahead and hit OK. And OK out of it. The minus sign is gone. So that'll be alright. Alright, so this one I'm just going to drag out. And no mate to start. We'll pick the faces. And we're going to try that profile center. Alright, so what do we have here? Counterclockwise rotation, clockwise rotation, and flipping the dimension or shifting the dimension on the center. So let's just see what that does. 1 inch. Well, it went somewhere. I'm not sure where I told it to go though. About 0.1. There it went. 1 inch was down. So I was like, how did that manage to disappear? Well, two objects occupying the same space again. Flip the dimension is going to leave a gap. So 0 is good. And we're not rotating about any of that geometry. So let's do a couple of profile centers. Face to face. File center. Let's check for the rotation. So as expected, it rotates about that center. So turning it upside down basically. Go ahead and accept. So if these blocks were oversized, you would have a large face with the small face. It would still find its way to center. All right, not ready to jump into the profile centers as my primary mate reference. Come back to it. All right, so item 5. Okay. So at this point, I have I just have the original part open. Don't really need that right now, so I'm going to go ahead and close it. I'm going to look at my cheat selection here. And going up to the next level, so this was one of the last parts to go in. Nope, was in the middle. So actually, this could be, it'd be kind of weird on the center of the part too. So, all right, so we'll go in with the L-shape. All right, new part, inch or assembly inch, and what is going to make this a? All right, so the L-shape was the 7, and we ran into the 1 and 7 here. So it is picked. I didn't pay attention to which configuration. So configuration 1, 3-block L-shape. I can do the pull down, go back to the default, and it will come back as the 4-block L-shape. Let's rotate it. So I'm rotating about the x-axis. Rotate it 90 degrees. I think I can work with that. And then we'll go origin to origin doing that. So it went fixed and origin of the part. Well, that was up there. So no, not really. All right, so we're going to end up floating that. So I'm not sure what I told it to pick, but I didn't get it. All right, so one of those and the top plane becomes coincident. And the front plane. So that whole control 7, returning back to the isometric, making sure I have the frame of reference, is just kind of a reset, making sure that I have that orientation in mind. All right, so we're going to bring in, let's see, the next one. All right, and so the instructions said that this was one of a million solutions, and I'm still having a hard time digesting that. So let's go with item 2. So insert component. We'll kind of jump around through these. Bring in item 2, and it's trying to pick up the mate reference on one of them. And let's go ahead and rotate. And we'll rotate about Z. Okay. Nope. That wasn't item 2. Okay, so let's go one more. Either that or I built it wrong. that would be a possibility. All right, so what I don't normally do is set this off to the side. I know that we have the 2 pieces. Typically, I'm going to recommend that you bring in one piece, get it fully defined, fully mated, bring in the next piece. In this case, if I were to bring in all 7 pieces and have them scattered around the screen, which one was the first one and what was its orientation, and now I'm lost. So systematically, bringing those items in is probably a better bet. All right, so item 4 is the other. And hopefully I didn't build the exact same thing twice. Or build it backwards. All right, so double check. That item 4 doesn't look like my item 4. I think I built one backwards. All right, so 2 and 4, those were the ones that I was getting mixed up on anyway. So let's see if we bring this over. No, they are opposite of each other. Okay. So okay, I think I see it. So the fun part of doing a puzzle while you're doing a lecture. Let's go coincident. Oh, don't like the orientation on that one, so I'm going to bring that, we'll close those up. And one of the things that I can set that orientation quick, but then I may have to come back and flip the mate alignment. All right, so rather than editing and then telling it to flip the alignment, I can expand out until I see that mate, and then right-click on it, and it will flip the mate alignment. So coincident and coincident. All right, so figured that one out, maybe. All right, and then the other item was from here to here. All right, so same thing. Didn't quite go the way that I wanted it to. Right-click on the mate, flip the mate alignment. Go coincident, and it is naturally rotating to its closest solution. All right, so even though I'm not going into those mates, I am getting the geometry in place. Okay, so the next one was kind of the zigzag. Yep, expanding those out. So we'll do a couple more with the mate reference. So insert component. Oh, that's just insert component. And not sure what I'm looking at, so we're going to go down through until we identify. So that preview is going to help me to pick out the geometry. Didn't quite want that, but notice that since I dropped it out in space, it didn't come up with an F, it didn't come up with an orientation, it just came in. So let's see, if we go this direction, go coincident, coincident, and and coincident. And at some point I really need to save assembly 7 to be, oh, some cube. Can't type. Yeah, it is some cube. Alright, so then we're going to insert. And we probably are getting close to item 6. So that one will go into face down. And it is somewhat random, but I would also say there is kind of a system or thing going on with the pick. I'm trying to, well, when the mouse is cooperating, I'm trying to match items that are close or from the same parts. Okay, so I'm not spreading it too far across for the geometry. Okay, so and that leaves the corner piece. Like I said, when I start pushing buttons, I revert back to the first. And nope, that one wasn't it. There we go, item 3. So item 3, I would like to rotate about X. Well, let's go close, and then we'll rotate about Y. That gets it in a little closer position. So face to face, face to face. And set the position. And then the last one was our item 7, 1 and 7 again. So if I scroll back up and I can find it, I can do the control select. And oh, it's the big one. Well, yes, it is, but we come down, let's go ahead and collapse all these up. We come down to the second instance, so the bracket or the, notice all these have the less than, 1 greater than. Those are all instances, one instance inside of the assembly. I mentioned that we're going to increment. If I happen to delete, I brought in 4 of the parts, the blocks. If I delete one, it got rid of number 3. Next one I insert is still going to be number 4, number 5. Number 3 just disappeared. It doesn't go back and consume something that's already been applied. All right, so at the very top we have the default, and I can apply the first block again. I can also, let's see, right click and go to component properties. And the advantage of the component properties, it's going to be able to manage display states as well as the configurations. So if I had these in different colors for whatever reason, and the display state was controlling those colors, I would be able to pick from those display states. All right, so face just doesn't like that part of the screen or what? Now it's either picking it and it's not letting me, or okay, that's just being really annoying. All right, so that's the case. Then we'll go interior. And then checking for movement, what's a good one to pick from? And it just does not like that face. That is interesting. All right, so I'm not sure what I told it to do, but probably didn't need to tell it to do that. All right, so there's our cube. And believe me, this is not the easiest way to do the puzzle. So if you try to do this, make sure you've got plenty of patience on tap, because this is, I would say, in the frustrating realm. All right, so to wrap up, then we still need to do the exploded view. We still need to bring this into drawing and create a bill of materials. All right, so exploded view, we can come up to the very top. The exploded will also be under, let's see, is it in? New exploded view will also be under that configuration. Probably added somewhere around 2010, 2012 era is when they let each configuration have its own exploded view. Before that, one configuration had the exploded view, the others, not so much. So we go with new exploded view, linear, regular steps, or radial. And we're pretty much going to grab an item and then pull in a direction. And up, I rotated it. Not sure I wanted to rotate that. Alright, so that's going to be interesting. And out. Oh, that just got confusing. Alright, so that one can go up. That one can go out. That one will go out. Up a little ways. Probably didn't pick that one very well. Let's pick it again. Nope, not happy with that at all. Really should have stayed more vertical so that you could see the progression and then come out a little bit. But that's going to get it far enough out. One of the things that I would probably then do is go back and come up with values that are a little closer to nominal. So apply, and watch out for the checkbox. So explode step 1, explode step 2, and the rotation. Now we don't need the 22.5 degrees. 0 is fine. Making sure to apply each time. Yeah, we got some 4 inches in there anyway. Apply. And a little bit easier when the screen is not condensed on resolution. Alright, so just to clean it up or be able to control it a little bit better. And Control 7, dimetric. Alright, so right click, get it back into the edit feature. Step 7 will bring out a little bit further. -3, see how much that overlaps the other way. Still not there, but closer. Alright, so doesn't really lend itself to the exploded line sketch, but we could put this face goes to this face and this face goes to this face and put those lines in, but probably more than I want to take on for this lecture. So I'll make sure to save it. Probably one of the more common errors that I see is that you have this exploded view and then you want to save it as a separate assembly with the collapsed and the exploded. They're the same assembly. All right, so if I collapse, there is my cube, and I explode, there is my exploded view. And we're going to be able to pick for those and jump back and forth without too much issue. We go into the animate, it's going to take it piece by piece, and we can put that out as an AVI file or little recorded video. All right, so collapse, and we'll make sure to save. All right, keeping my fingers crossed on the sheet format again. 2017 updated on me, so formats. Did it lose it? Nice. Either that or because I told it was 2018. No. All right. So that'll do. Model view, the cube, and then under the reference configuration, it's still default, but notice that there is a checkbox underneath that says show an exploded state. Exploded view 1, and it's exploded, and we're set for isometric. And we'll go ahead and place it. Oh, good, all the origins are on. Let's turn those off. Okay, so we have the origins out of the way. And then one of the things that we would like is the auto balloon. Well, it found one of everything because we were at the part level. So faces, edges, and it's not naming or hasn't picked up for ignore multiple instances. Well, if we turn that off, there are lots of number ones because everything is a number one. So when we tell it assembly size, we have the balloon text, item number, quantity, part number, file name. Interesting that it is not picking up the sub-assemblies. I kind of am missing that. The magnetic lines are the verticals that'll let me drag. Okay, so can't say that I was expecting that. Another one to look into, since it's picking up the part file instead of ballooning to the sub-assemblies. So chances are there's a checkbox somewhere that I don't have checked. So we'll try again. Right-click, table, bill of materials. Found my default bill of materials, top level only, parts only, and indented. So let's take a look at the top level. Underneath is configurations of the same part as separate items. So 1 and 7, we would have an item 1, we would have an item 7. Missing incrementing numbers, start at and increment by 1. Border and the look of the table, and then what layer it's on. And haven't set up the layer in this template, so go ahead and accept it. Place it. Default has the description. We haven't set a description, so I'm going to delete that column, which will pull it in a little ways. As I go through and make the corrections on these items, then I would pick up this template, save it back, refine it, have a my standard template. All right, so 1 and 7 because I left the default at its common name, at the part name. Everything else picked up a configuration name. So what I'd be interested in now is, does the auto balloon, yes, pick up the instances to relate, or the sub-assemblies to relate back to the bill of materials. Before we get out of this, we're going to pick the sizes, bring it in a little bit, make sure that this is manageable. If we go with the magnetic lines, all right, so we'll leave that on so we can get to the magnetic line. Maybe the up was pretty good. All right, we'll go with the up. Still dragging a lot on top of the other parts. Faces or edges, do you want it a dot in the center of a face or an arrow pointed to the edge? Minor details, but it affects the look of the drawing. All right, so when I click on one of these, there is my magnetic line. The magnetic line drags all of those balloons as a group, and then we'll stretch or shrink as a group. And not great, but not bad. Decide that everything looks good except for maybe number 4 here. Number 4 can be drug out, and okay, you're all by yourself. Okay, maybe 3 too. Nope, don't like where that arrow is at. Pick a new anchor location. All right, so pretty flexible. Let you go through and pick up those items, make a decent preview. If I'd put my my explode view a little bit better, let's see what the dimetric looks like. Oh, that's just wonderful. Not much better. Going to stay with the isometric because I'm only digging in deeper. All right, so I would think about the order that I pulled those out in, the directions that I wanted them to go out. A lot of the prismatic shapes, the assemblies, the automation equipment, the little gizmos and widgets that we build on a regular basis, they have a natural order of assembly that doing these explode views makes much more sense. All right, so same basic process, build a part. You know, this one had the both the luxury and the pain of being a part in different configurations, different orientations. saved as subassemblies. And then if I wanted to, I guess the next level up would be to get back into that, and we'll save the drawing. Go back into the cube, set a file new. All right, so summary 0, 2 files were suppressed. Really? Wonder why. All right, so my subassembly and its subassemblies, so each have the same icon. We tunnel down a little bit deeper, then we see the part icons, and then we can still tunnel down even deeper and get back to the features, the sketches, those individual items. Decide that I want to bring all of these in, and we are and we can start building up on the cubes. Each of those get mated, and I think this is probably the best illustration of why I turned the origins off early. Is that's a lot of origins.